Welcome, everyone. We're so excited you're going to join us tonight for this webinar. Before we get started, let's do a little audio check. If you can hear us, all right, if you could raise your hand, you'll see that in the right-hand column in the little GoToWebinar control panel. If you can hear me, let me know. Raise your hand. If you can see that, is there a raise thing? All right. Thank you. Thank you very much. And Mike, could you say something so we can see if we can hear you also?
Something.
All right. So we will get started. We are muting all the participants for the sake of audio quality. So if you have any questions, and we welcome questions tonight, please use the question panel on the right-hand side, and I will be answering the questions. If there are several questions, we will let Mike know so he can address the questions as we go through the webinar. But we're pleased to introduce Mike Reiners, who's joining us again from St. Paul, Minnesota, where he serves as Math and Science Department Chair at Christ Household of Faith. We are so lucky tonight to learn from Mike's experience in everything Casio, including his excellent keyboarding skills. But today he will continue his webinar series on programming with Casio graphing calculators. So Mike, I will give you the power to show your screen, and I think we're ready to get started. All right.
All right, thanks very much, Jen. And welcome to everybody who's joining us this evening. As Jen mentioned, my name is Mike Reiners. I'm the key advisory teacher for mathematics for Casio Education in the U.S. So I do a lot of workshops and webinars and presentations on Casio calculators, mainly focusing on proper pedagogical use of technology in the classroom. Everything from calculators to computers to emulator software and a lot of the different technology that Casio offers. But one of my great loves is programming. I've had a love for programming graphing calculators ever since I was a student. It's one of the first things I ever programmed. Maybe an Apple IIe, which dates me a little bit, but my programming experience basically started writing in the basic language on a computer and writing in some of the basic languages that are used on calculators. Many of the graphing calculators have very similar programming languages. TI and Casio in particular have very similar programming languages. Some of the commands are different, but most of what you can do with the two calculators is similar. There's a few extra commands and bells and whistles that Casio has that I think you'll find useful. But for the most part, a graphing calculator is in general a great way to teach students how to begin thinking programmatically, begin thinking of ways and commands that can be used to tell a machine what to do, and to give proper syntax and proper instructions, and to write very simple methods that allow you to accomplish basic tasks, maybe solve mathematical proofs and extend patterns and see where the mathematics is taking you. So in our last session, last Wednesday, we talked a little bit about the basic ways to cause the calculator to ask for an input and to cause the calculator to provide an output. And we wrote a simple program last week that allowed the user to input the values of A, B, and C in a standard form quadratic equation, and then the calculator would output real number results that would come from the quadratic formula. So if you'd like to learn more about that, if this is the first time you're joining us, that webinar should be posted very soon, if it hasn't been already, on Casio's webinar channel. And you can find that and learn more about that from CasioEducation.com, and we'll refer to it again at the end of this webinar. But tonight we're going to move to the next step and get a little bit more advanced with the programming commands, and we're going to talk about loops and ways of causing repeated actions in a program. And as with each one of these webinars, we don't just want to throw out random information about calculator commands, because that's kind of boring. The best way to learn programming is to start coding something, to start programming something. So we're going to write a program tonight that is going to attempt to determine whether a number that has been input by the user is prime. So let's get started right away. Tonight the calculator we're going to use is the FX9860G2, as you can see up here on my screen. Last week we used the 9750G2, but for those of you that participated last week, there really isn't any difference in the calculator models that we're using here. You have a little bit more capability as you go up the graphing calculator line with Casio, but one of the great things is that the vast majority of the commands are the same, and the keypads on all of the calculators are exactly the same. So if you were with us last week, you'll notice that this keypad may be colored differently, but that all of the keys are in exactly the same place. So you could actually use this calculator to walk through every single step from last week's webinar, and you wouldn't miss a beat. You wouldn't get confused about what's where. You wouldn't get confused about where did this command go. Everything is in exactly the same place. So important to remember that Casio's calculators are designed to grow with students and to grow with any user as they move from model to model. So we'll start in the main menu here, and we're going to go into the programming module, which you can see is in the bottom right-hand side here of our main menu. And we can get to that by using our arrow keys and highlighting program, and then pressing the execute key in the bottom right-hand corner. Or we could also simply have pressed the key that has the letter B above it, which happens to be the logarithm key. Calculator knows we're not going to try to take the logarithm of the main menu, so it's pretty smart that way and says the only sensical thing you could be doing here is generating a B for program. So if we press log, we'll go into the program list. And right now we have no programs. So in order to create a new program, we talked about this last week, we have to remember that on a regular handheld unit, all of these F1 through F6 keys would appear directly beneath the screen. And so where it says new here on the bottom of the screen, it's indicating to create a new program. I'm going to press the F3 key. And I'm going to turn on recording now so that you can watch and see key.
Mike, your audio is kind of going in and out.
Keystrokes appear, and if you're watching up on keystrokes, if you miss something later. So let's press F3 and create a new program. We have a alpha-based cursor here, and I'm just going to move this back up so that you can see all of the keys. And we're just going to call this program prime. So let's press the keys corresponding to P, R, I, M, and E, and then press the execute key. And so here's our program called prime. If we're going to determine if a number is prime, the very first thing we need to do is ask the user to input some natural number, some counting number. So if you'll remember from last week, the way that we generate an input is by pressing Shift and then the variables key, which has the program commands above it. Anything in yellow is activated by pressing Shift first. And here are our programming menus along the bottom of the screen. And the way we generate an input is with a question mark. So again, remember where those F1 question mark, the input prompt is above F4. So we're going to press the F4 key here. And then we need this input to be stored into a variable. And when we're talking about counting numbers, we very frequently use n in mathematics. Think about mathematical proofs by induction, or anytime we talk about a number belonging to the set of natural numbers, we tend to use n. So let's take this input that the user is creating and store it, pressing the storage key here, this right-facing arrow. We're going to store it into the variable n. So we'll press alpha and then the key with the n on top, and that prompts us to create an input and store it into n. So we'll press execute, and there's our end of line character, and we have already a first line in our program. Like we talked about last week, good programming technique says that you should always get out of your program editor frequently and test your program to see if it's doing what you think should be happening. So let's do that now. We're going to press the exit key twice. The first one gets out of our program menu at the bottom, and the second one gets out of our program entirely. Don't worry, this line again is not telling you that 36 is prime. It's just telling you that our program has 36 bytes of data in it. That's its storage size. So to run our program, just press the execute key. There's our prompt, kind of bland and plain, but we could input a number. Now, remember, the calculator doesn't know that it's supposed to be receiving a natural number. Just because we used n doesn't mean we've activated some magic determining software in the calculator. The calculator says you can enter anything you want. So right now we could enter pi, for instance, and the calculator would think that's just fine. Good job, it says. You've just stored the value of pi into n. So one of the things that we want to make sure we do is what's called error checking and input checking of our users. If we want the user to input a natural number, then that means we need to put in some if statements in the program that make the calculator determine if a natural number has actually been entered. And again, if you think about the title of our webinar tonight, we're learning about ifs and loops. So if statements and loop statements. So we'll press the exit key, go back to our program list, press the F2 key for edit to get back into editing our program. And we're going to arrow down to the next line. And we need to do some checking about what this value of n is. So, we know some things about natural numbers. We know that natural numbers certainly are not zero and they are not negative. And we also know that they have no fractional part whatsoever. So we're going to create an if statement that accounts for both of those things. Let's press Shift and then the variables key to get into our program commands. Here they are. And now we're going to look at some of our commands and controls here. Let's look through these menus and see what we have. F1 for commands. The very first thing we see is if. So press F1 for if. And one thing I want to stress here is even though this looks like text, you cannot start simply typing text into the calculator. You could not create an uppercase I and a lowercase f and have this be an if statement. The calculator treats this command as different than text. So please understand that if you want if as a program command, you must get it from this menu. You cannot simply type the word if. You will get syntax errors and all kinds of breaking parts of your program. Always get your if statement or any specific program command from the program menus. So we have an if statement. And one of our conditions should say that if n is negative or 0. So we need if n is less than or equal to 0. And I need to show you where to go and get the less than or equal to command. We're going to press the exit key to get out of the command menu. And we're going to press the F6 key to go to the next page. And then above F3 you see REL, which stands for our relational symbols. Press F3. And here are your equal, not equal to, greater than or equal to, and less than or equal to. We are going to choose F6 for less than or equal to 0. So if n is 0 or a negative number, we would really not like the program to continue. In fact, we would like it to force the user to put in a new value. But that's not the only condition we need. The other condition that we need is if n has a fractional part, we also have a problem. It could be positive, but if n is pi, for instance, it has a fractional or a decimal part, and we would like the program to reject that input also. So what we need here is an OR statement. if n is 0 or negative, or if n has a fractional part, then make the user put in a new value of n. So we need the OR connector. And again, you can't just type in OR as text. The calculator thinks that's a variable O next to a variable R. So we will press the Option key and then F6 for the next page, and F6 again, and we will choose the Logic menu here above F4. So notice that these are not actually programming commands in the Program menu. These are in the Option menu because these are not just specific to programming. We know as mathematics teachers that we use and or and not and things like that all the time in study of probability and all kinds of things that don't necessarily have anything to do with programming. So this command, this OR connector, is not a specific programming command. It's stored under Option. So if n is less than or equal to 0, or, and then let's press Option again, F6 to go to the next page, and let's look at some of our numerical functions, F4 for number, numerical. And here where it says frac above F3, that is going to be the fractional part of our number. So we're going to press F3 for frac, and then create an n. And if this fractional part of n, in other words, what comes after the decimal point, if this is anything other than 0, we have a problem. For example, when we put in pi, the fractional part of n would have been 0.141592, and so on. And that's what creates a problem. That's what makes it not a natural number. We need nothing to exist after the decimal point. So if n is 0 or negative, or the fractional part of n, the part of n that's after the decimal point, is anything other than 0, we have a problem. So let's go back to our program commands, shift variables for program. Next page, relational symbols again, F3. And we're going to grab the not equal to symbol. If the fractional part of n is not equal to 0, if it is anything other than 0. So these are our conditions. Think of us teaching students about conditional statements in geometry or any study of logic. If n is less than or equal to 0, or the fractional part of n is not equal to 0, if either of these is true, then what? Well, we don't put the then at the end of this statement. We write the if, press execute to end the line, and now our then is going to exist on the next line. Very important to remember. So we're going to press the exit key, F6 twice to go back to the first page of programming commands, and then F1 for command menu, and F2 for then. So our then statement goes at the next line, the line after the if statement. If one statement, then one statement. And in fact, you can have all kinds of things coming after then. You write then, and we can have a command here and a command on the next line. We could do 80 commands after then. It's fine. This is all contained in our if statement until we use what's above F4, which is if end. If any of you have done any programming before, that's like a closing bracket on your if statement. It tells the calculator when we're ending our if condition. So what do we want to do if they put in a bad value of n, a value that's not a natural number? Well, we'd like to go back up to this input line and make them enter a new input. All right? So let's figure out how to move them back to this place of the program. We're going to press exit to get out of the command menu, and we would like the program to jump from here back to the top of the program. So we use our jump menu, F3, press F3, and we are going to use F2 go to. Now, if any of you have programmed before, you might cringe when I use a go to command, but you really need to remember that this is not a full formal programming language. We cannot write 17 different functions that call on each other like we can in in a typical programming language like JavaScript or C# or C++ or Pascal even. We're in a basic programming language, and a fundamental aspect of the basic programming language is labels and gotos. You want to avoid using them if possible, but in cases like this, it's really a very innocent use of the command. So we're going to say then goto, and we're going to type a 1 and press execute. Now, if we're telling the calculator to go to 1, then it had better know where 1 is. So we need to label where 1 is. So let's go with the up arrow right to the beginning of our first line. And I'm going to press execute there to create a carriage return, an end of line. So it basically is a cheap way of inserting a line prior to a command by pressing execute at the beginning of a command line. So right here at the beginning of our program, we're going to press F1 for label and type a 1. And I don't need to hit execute again because I already have an end of line character. So right now what should happen when the program first runs, label 1 doesn't tell the calculator to do anything other than remember this spot. The next line should cause our user to input a number. The next line after that should ask the condition if n is 0 or negative, or it's got a fractional part, then it's not a natural number, so then go to 1. The only thing we need to do to complete this little section of code is go to the bottom line, press exit here, F1 to go back in our command menu, and end the if statement. This is a common mistake, just like in any programming language. You'll hear programmers talk about all the time. I forgot my ending bracket. I was missing a semicolon. All these things that need to happen at the end of lines that tell the calculator that a line or a set of commands is done. Press F4 for if end. That's a statement in and of itself. Press execute. And now we have a complete set of code that operates together. Let's test it. Press exit a few times to get back to the program list. Our program has grown in size. We have more lines of code. Let's press execute to run it. We're prompted for a number. Ha ha, says the student trying to break the program. I'm going to enter pi again. It worked last time. Press execute. Oh, a question mark. Our program gave us another input. Well, okay, 5.2. Execute. Question mark again. Why can I not break this program? Says the finicky student. Oh, let's try -3. Doesn't work. How about 150,000? Well, that's a natural number. And so when we press execute, our program ends. It got to that if statement, and the if statement was not satisfied. So the program ignored everything that came after that and realized, I'm at the end of your code. So good job. I've stored 150,000 into n. So we have successfully used an if statement to reject improper input from the user. Now, we got a couple of problems going on here from a prettiness of program standpoint. One is that it's kind of ugly looking for question mark number, question mark number, question mark number. And we also are giving the user no information as to why their previous prompts are incorrect. In fact, if a user didn't know what our purpose was in writing this program called prime, they might not have any idea what they're supposed to enter. So let's go back and enter some text and give them some hints as to what's going on. This is just good programming technique. We'll press the exit key, F2 to edit our program, and we're going to insert a line between label 1 and our input line. Again, we'll go to the beginning of the input line, press execute, and we've now inserted a line in between. And we'd like to give our users some information, but we'd also like to make sure that every time that we come back and reject a user's input and go to this labeling spot, that we clear off all of the clutter and nonsense that's been accumulating on the screen. So the first thing we're going to do here is input a command that clears the screen. Get there by pressing Shift and variables to get to the programming commands. Press F6 for the next page. And CLR above F1 are all of the clear commands. Press F1 for the clear menu. And all we want to do is clear all the text on the screen. So press F1 for a clear text command. This is a great command, and I really recommend almost always using it at the beginning of your program. That way, if the user's been doing something else in the calculator, you really have no idea where they're coming from or what they've been doing when they enter this program. If you want to start fresh, start your program with a clear text command. And then we'll go down to the next line and go in front of the question mark. And if you remember from last week, when we include the input question mark, we can put text right before that question mark, and then the question mark will display at the end of the text. So let's phrase this like a question. We'll press Shift Alpha to put the calculator into alpha lock so that everything we type from now on uses the red alphabetic characters on the tops of the keys. We'll put a quotation mark for text that the calculator should display. And then let's type in which, and we'll press a period to create a space, which natural space number. Oh, I missed a character. It's okay, I can just arrow back and insert it. Which natural number, space, would you like, space, to check. Closing quotes. We don't need to put a question mark in because the input question mark, if you remember, was already displaying by itself. So let's just run this part of our program and see how the clear text and the message has changed things. Press exit a few times to get back to your program list. Press execute. And we get some text and a question mark. Which natural number would you like to check? Already a hint to the user. Hey, buddy, please put in a natural number. Ha ha, says the student. I'm going to put in pi. Execute. Up. If statement catches it and drops us right back, clears our screen, and makes the user feel like they have not done what is being asked. Well, that's right. This is what input and error checking is all about. If you want to, you could go in and give a message to the user that says that the number they entered is not a natural number. The first thing I'd like to do actually is fix our word wrapping here. You see that the calculator does not automatically word wrap text. So I'd like to move these 3 letters of check to the beginning of the next line so that it flows nicely on the screen. But I'm stuck in the middle of my program. If you want to get out of the middle of a program before executing it all the way through, simply press the AC on key on the right-hand side of your screen, and that will break out of the program. Calculator prompts you to press exit, and very nicely brings you into the program at the exact place where it broke, where it stopped executing. This can be really useful for error checking your program, checking for bugs, seeing where things are breaking, and so on. Let's move our cursor over to right before the word check. Press Shift Alpha to go into alpha lock. And since we had 3 letters of check stuck on the previous line, let's press the decimal point key to create 3 spaces. 1, 2, 3. You can almost get a clue here as you look at the screen that even though it's shifted over because of the quotation mark, you can see how all of these 3 lines line up very nicely, and that's kind of a clue that you're going to get good behavior out of your text when it appears on the screen. So let's press exit and run the program, and you can see that we have very nice looking text now. Just taking a quick pause here. Let me take this opportunity to ask if there are any questions up to this point. If anyone has one, feel free to type it in or raise your hand.
We have a couple questions. One is, where do you find the syntax for all these commands?
Okay, the calculator manual is the best place actually to look. I know calculator manuals can be kind of imposing, but one of the nice things is that Casio has all of its calculator manuals in PDF form, not just paper form. So in fact, if you look at the emulator software that I'm using, the emulator software in its help menu has a manual item here, and there's a manual for both the software, which has nothing to do with the calculator, just how to operate this software that I'm using, and the calculator itself. So I actually went here earlier before the webinar started to manual and calculator, and all it does is goes and finds the PDF file of the calculator manual on your computer and pulls it up, and it's a fully searchable PDF. When you first load the PDF, you'll see the contents in your bookmarks on the left-hand side, and where you want to look is in Chapter 8 for programming here. And the place to start always is on number 5 in Chapter 8, called Command Reference. And if you click that, you get to this page that I'm showing you right here. It shows you every programming command. So these are all of the commands that you would see appear in that program menu that we have been getting to by pressing Shift and Variables, the program. It shows every single command, and so if we want to go look at syntax, for instance, let's go and look at the syntax of our input command here. Input command is on page 8.8. We're on page 8.7, so it's going to be in the very next page. I'm just going to scroll down to the next page here. Here's page 8.8, and here's our input command. What does it do? Prompts for input of values for assignment to variables during program execution. What's the proper syntax? Well, you can use question mark, storage arrow into a variable name, or here's another option, a prompt in quotes, like we just typed in, followed by the question mark and storage into the variable name. Here's an example of a piece of code that would work. And then here's some additional information. What kinds of variables you can use, what kinds of things the user can input, and so on. So this page here with command reference is a great place to start. It tells you the page in the programming area to look for, and there's all kinds of good examples and good syntax. And in fact, the programming chapter also at the end has an area called Program Library where they have a number of excellent programs that you can look at in order to find examples. And some of these programs are very useful in their own right. These aren't just examples, they're great programs. So here's a program, for example, that allows you to perform prime factorization. That's a little bit more than we're doing tonight, but you notice here they typed in the number 462 and it's generating all of the prime factors. And here's all of the text that you can use for that prime factorization program. So you get an idea of how commands work. There's a much longer program that comes afterward that allows you to create an ellipse and give you some information. And that's it. It goes on to chapter 9 now. But there's two very excellent program examples. One super easy one with just 10 or 12 lines of code, and another more complicated one with 25 or 30 lines of code and some more higher level commands. So that's where you would go and find information on commands and the proper syntax to use.
Thank you very much, and thank you for sharing the help menu with us. I think that's all the questions for now. We'll check in again at the end.
Okay, sounds good. So back at our program, we see that our text is in the right place. I'm going to press all clear now, break out of my program, and let's go down and do some other things. So I'm going to go to the very end of our lines of code. We now have set our code in such a way that the user has to input a natural number. So we now know that by the time we get down here in our program execution, that the user will have given us a natural number and the calculator has stored it into n. So now what are we going to do with n? Well, we need some kind of a process by which the calculator will check whether or not n is prime. And for the purpose of this program, all we're going to do is tell the user that the number is prime or that the number is not prime. And we're even going to give them a little bit of an extra bonus. If it's not prime, we're going to tell them something that the number is divisible by to prove it to them. So we need to create a loop because the calculator is going to check a whole bunch of numbers for divisibility, starting with 2. So the first thing we're going to do is create a variable d that is going to be our divisor, the thing we are going to check for division by. And we're going to start checking for divisibility with 2. So we're going to store 2 into the value of d. But we want the value of d to change. We would like the value of d to get larger and larger. Check 2, see if it works. Check 3, see if it works, and so on. So we're going to create a loop, and we're going to press the Shift key first and then the variables key to get into the programming commands. And then we're going to press F1 for command. Our first page had to do with if, and pressing F6 gets to our second page, and here we see what's called a for loop. Now let's actually go to the calculator manual and look at the proper syntax for for loops so that we can use what was just asked in the previous question. For is on the very next page here, 8-9, and here is our for loop. So our syntax is for a starting value stored into a variable name to an ending value. So think of it this way. We type the for command, and then we say what value we want our variable to start at, storage into what the variable name is, and then we want to go to whatever the ending value is. So I just told you that we wanted to start our divisor at 2, and then we want to go up to some stopping point. Okay. So back to our code. Let's press F1 for for. 2 stored into the variable d. So starting at d equals 2 and going all the way up to TL command. Well, what do we want to go up to? Obviously, the easy, quick answer is, well, you want to check for divisibility from 2 all the way up to your number. But this is where we can actually use a neat little result of number theory, which is that no number is going to have a divisor that just exists by itself and doesn't exist in a factor pair. In other words, if my number is divisible by 2, then it's going to be 2 times some much larger number that equals n. And the only thing that can disobey this and actually be a factor multiplying by itself would be if the number has a square root that's a natural number. In other words, if it's a perfect square. So really, when we're checking for factors, we don't need both numbers in the pair. We only need the lesser number in the pair. So we only need to check from 2 all the way up to the square root of whatever our number is. And this square root may not be a natural number. It might be an irrational number. It might be a decimal. It's not going to matter. In a for loop, what the calculator is going to do is increment this number 2 by 1 at a time until it gets to a value that exceeds the square root of n. Once it goes beyond that, it's going to quit out of this loop and say, I'm done repeating this process. So we'll press execute here. And now we tell the calculator what we want to do with this value of d each time we go through the loop. Well, we would like to check if n is divisible by d. And if you think about what divisibility means, it means there's no remainder. In other words, there's no fractional part. So if you think about what we were doing right up here in this line of code here, the fractional part of n not equal to 0, we would like the fractional part when n is divided by d to be 0. If it is, the number is not prime. That means that n is divisible by d. So we need to check for that divisibility, and we're going to use that fraction command again, that fraction part command. Option, F6 for the next page, F4 for the numeracy menu, F3 for fractional part, and we would like the fractional part of n divided by d. Notice the parentheses, very important here, otherwise we're looking at the fractional part of n by itself. Close parentheses. And we want the fractional part of n divided by d to be 0. No remainder, meaning the number is divisible. So option, programming command, shift program, next page, relational symbol. We're checking if this fractional part of n divided by d is equal to 0. Okay, press execute. Now please realize that this is not a complete sentence in programming. We need an if statement here. If the fractional part of n divided by d is 0, then do something else. Then we want to tell the user that the number is not prime, that it's divisible by whatever d is. So let's make an if statement. We'll go up to this line. And of course we could input if, just like we had done previously, but I'm going to show you a different way to make a conditional statement. We're going to go to the end of this line, right after the 0, press exit to return to the programming commands. Next page twice to get back to the beginning here. Press F1 for the command menu. And then next page, next page. I want you to notice that this if command that we are grabbing is not in the same place as this if command. I would actually really like it if Casio had stuck it right here above F5. But the reason that it wasn't there is it wasn't there in previous models of their calculators, and they don't like to confuse users by moving commands around. So we're actually going to go into the F3 menu for jump. And above F3, you can see this implies arrow. You should be familiar with this as math teachers. We use these in conditional statements all the time. If then. Statement P implies Q. So we're going to press F3 to say, basically, if the fractional part of n divided by d is 0, then do what? Well, if it's equal to 0, we would like to completely leave this for loop and tell the user, we're done, this number is not prime, it's divisible by whatever d was. So we're going to go to label 2. And to be good programmers, we'll go and we'll right away create a label 2, and we'll figure out where exactly that's supposed to go in a moment. So if your number is divisible, get out of this checking. You don't need to check anymore. We've found that it's not prime. Now, what happens if this fails? If the number is not divisible? Well, then we need to continue going through the loop. We need to say, well, it wasn't divisible by 2. Make d1 bigger. Is it divisible by 3? If not, make d1 bigger, and so on to the square root of n. So we need to tell the calculator to make d the next value in order. So to do that, exit out of the jump menu, go back to the command menu, page 2, and input a next command. The next command marks the end of the for loop. A for loop must always be closed with next, just like an if command must always be closed with if end. A for command must be closed by a next. So we're going to loop, 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 check 2, check 3, check 4, check 5. If we ever get a divisible number, we're going to go to label 2, which is down here. And then we need to tell the calculator what to say. Well, if we have divisibility, we would like to tell the user that the number is not prime. So let's simply display a message to our users. Let's type n, and let's just see what that does. Just typing n. Let's see what the calculator does with that. Let's go test our program. Exit, exit. And run the program. Which natural number would you like to check? Well, let's check something that's not prime and see how the calculator pops out of this loop. So we know, for example, that 78 is not prime. Press execute. Hey, it displayed 78. That was n. Let's try something else. Let's edit this program. Go down to the bottom, and now here's where these commands that automatically appear when you first edit your program are really useful. I don't want to be at the top. I want to be at the bottom. Easy. Press F2. You're at the bottom. And now let's also type in a D and press execute and see what the calculator does with that. See if it gives us our original number and the divisor. So execute our program. Check 78. 2. Uh-oh. So our calculator displayed D, but it did not display N. So we got to force the calculator to display these values, and we have to do it in a little bit different way than we have right now. So let's create some text. After N, let's type a comma, and then Shift Alpha Lock, quotation marks, a space, and is not space prime. Turn off Alpha Lock to type the period, and then alpha quotes. Let's see what this does. Exit, execute. Check 78. Syntax error. Uh-oh. So the calculator does not like this display of n. So how are we going to get the calculator to display our number? I'd like it to display the number is not prime. Well, consult your reference. How are we going to get the calculator to display things? Let's go up to number 1 here in our manual and look at basic programming steps. And we'll scroll down a little bit. Here you can see the calculator is giving you a very nice example program to calculate the surface area and volume of some shapes. That's very nice. And you can see a list of some of the commands. We're looking for how does the calculator output information. Oh, file management, none of this matters. Here's our command reference. And let's see if we see anything here that talks about output. Well, if you can spend a lot of time looking for this, and you'll see this output command, and this is the command that we talked about last time. But the output command, unfortunately, pauses the screen. So if we were to create an output command, it would just display some information and then cause a pause. In fact, let's go look at that right now. This command momentarily interrupts program information execution and displays text or the result of the calculation immediately before the command. So unfortunately, it can only display one thing at a time. And so that's not going to help us very much. This is why it's important to watch webinars, because you may not even know that the command that you're looking for here is called locate. Locate is an incredibly useful command for outputting text. And we're going to go look at page 17 in our programming area here and learn about locate. Locate displays alphanumeric characters at a specific location on the text screen. And it locates text by telling it a column number, a line number, and a value, or an expression, or a string in quotes. So this allows us to put text or values of variables anywhere we want. And this is how we build lines of text and lines of output to our user like we're trying to do now. So this is a little more advanced method of output than we were studying last time. Let's go back to our program. And I'm actually going to press a carriage return here and get rid of the comma by pressing the delete key for backspace. And so what I want before this n is I want a locate command. I want to locate n. And I have a pretty good idea of where I want it to go. So let's first of all run our program and see what our screen looks like. Okay, the first 3 lines are taken up. And then we're going to type something on the 4th line. Well, maybe then we would like the result to our users to come out on the 5th line or even the 6th line so that we leave some space. We would maybe like it to say right here, 78 is not prime. Okay, let's see if I can use my neat little pen here. 78 is not prime. I don't know why my text is not staying on the screen. Maybe you can see it. But GoToWebinar is not liking me writing all at once. But you get the idea. We want our text to appear on line 6. So we're going to break out of our program right now and go to the bottom and go up prior to this n and create a locate command. Shift variables. For our program menu, go to the next page. We want our display commands in F2. Oh, locate isn't under display. You'd think that it would be, but this actually has to do with displaying a graph or displaying a table or displaying something else from the calculator. What we're working with right now is input and output. So this I/O menu is where you're going to find the locate command. Press F4 and F1 for locate. And the syntax is column, so we're going to display in column 1, comma, the row 6, comma, what you want to display. So we're going to put the value of n at the beginning of that line. Now, we have a little bit of a problem because we don't know how long n is. What if the user had entered 10 billion, a massive number? Well, then it might take up a lot of space, and we don't know how much space it's going to take up, so we might not even be able to put is not prime on that line. It may not fit. We only have, if you'll count with me here, we only have, let's go down to this line and count our characters. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Let me just put these in here. 18, 19, 20, 21. You have 21 characters on a line. So we've got about 10 characters of text, 12 with spaces, and we may not fit if they put in a really large number. So at the beginning of this line, we're going to go to the input-output menu and put in another locate command, and we're just going to put it on the next line. Column 1, comma, row 7, comma, is not prime. Okay? Good. Let's exit and run our program. What would you like to check? 78. 78 is not prime. Here's a 2 that it's displaying for us. Kind of, why is this 2 up here? Well, in fact, we don't even necessarily need to say 78 is not prime. We could say 78 is divisible by whatever d is. So let's go back into our program, go to the bottom, and let's change this text to say is divisible space by space. And now let's count our characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So that means we want to start displaying D at column 18. Programming commands. And then input output, locate. Column 18, comma, row 7, comma, D. Exit, run the program, check 78. 78 is divisible by 2. That's kind of cool. That's a proof that it's not prime. So now the only thing we have left to do is put in a command if the number is prime. So, edit the program, go to the bottom, look at where our loop ends. If we actually get through this entire loop, and there has not been anything divisible that cuts us out to label 3, then we would like the program to say that the number is prime. So, let's use another locate command. Locate 1, 6, n. Locate 1, 7. Column 1, row 7. Oops. Back there and get that. And then alpha lock space is space prime. Period, quotes. Now, it's very important that we not let the calculator get to this next set of information. If it's prime, we don't want it to then go and say it's divisible by something. That's going to create a mess. So right after this line that says it's prime, we need to tell the calculator we are done. Stop running the program. So exit out of here. And let's press F6 twice. F2 for control of the program. And we would like the program to stop. Press F4. Let's run our program. Check 78. Okay, we knew that. Let's run it again. Check 79. 79 is prime. Notice it didn't say is divisible by anything. And do you see how fast the calculator checks this? It can go through that loop really, really quickly, especially since we're stopping at the square root of n. Let's try something huge. I'm just going to type a bunch of characters and end it with an odd digit in the hopes that maybe this is going to be prime. Uh-oh, it was divisible by 3. Well, let's cheat. We'll very quickly go to the main menu and go to number 1 for the run matrix area. And let's take 2 large prime numbers that we know about and multiply them together. So, for instance, let's take 37 times 79, 2,923. Or even better, 79 squared. Then the calculator is going to have to check, we know, up to the square root of this number all the way to 79. So let's go and put in 6,241. Menu, B to get to the programming area. Run the program. Uh-oh. I need some help from my participants. I've already forgotten the 4-digit number. 6941, is that correct? Let's try it. Nope, that wasn't it. But I do see that 6941 was divisible by 11. I'll go check quick. 6241. Ugh. 6,241. And look how quickly the calculator determines it's divisible by 79. So there you have it. You have a program that checks whether a number is divisible by anything. In other words, it simply tells whether a number is prime or not. And you can do all kinds of things to modify this program and add some bells and whistles. But we're at exactly an hour. Our time is up. So let me just very quickly remind you of what we've gone through in this if statements and phrasing them in a couple of different ways. And we've learned about for loops and how those work. And that's the intent of this program, is to show you some of those commands.
Mike, we have one more question, and that's, will programs written on one calculator transfer to another calculator, another Casio calculator?
Yeah, the Casio calculators, any calculator that you see that has G2 here is part of the second generation of Casio calculators, and that includes the FX9750 G2 and the FX9860 G2, and also the Prism calculator. In order to transfer, so they're all written in the same programming language, and they'll move from model to model. You can use the link cable that comes with all of the calculators to transfer programs from one handheld to another, and they'll transfer just fine. Older model of Casio calculators, there's some hoops you have to jump through. Those of us here at Casio can certainly help you with those.
Muted.
If you'd like to do something like that, you can just shoot us an email. Contact us through the Casio Education Help Desk. But you can absolutely transfer programs. FX9750 G2, 9860 G2, and Prism all use the same core programming language, and they transfer and run quite well. If you use a command that exists on the Prism, for example, that doesn't exist on the 9860, then you may have problems in your program. But there are so few of those that you will almost never run into any difficulty. Any of this stuff that we're doing here is very basic programming stuff, and but it really is almost all you need to write just about any.
Unmuted.
Any other questions?
I think that's it. Well, thank you, Mike, so much. That was very informative. I was able to do my program on my Prism as we went along, so this is fantastic. I'd like to remind everyone that this webinar will be recorded, and it will be available on the Casio YouTube channel shortly. And I'd also, Mike, I'm going to change presenter and steal the show from you and show my screen.
Mm-hmm.
I would like you to share that if you need additional information or would like to view other webinars or get some more information, the Casio Education website has several resources, documents you can use, actually classroom activities, which you can use in your classroom at any time. So feel free to explore that website. Mike, if you have anything else, I think this is fantastic. So.
That's it for me.
All right. Well, everyone, enjoy your evening, and thank you so much for joining us. Bye-bye.